Water, one of the most common and essential substances on Earth, behaves in ways that often surprise even the most seasoned scientists. While we are accustomed to seeing water boil at high temperatures and freeze at low ones, there exists a special and unusual state where water can actually boil and freeze at the same time. This seemingly paradoxical phenomenon is known as the triple point, and it occurs under very specific conditions of temperature and pressure. At the triple point, the three phases of matter, solid, liquid, and gas, can coexist in perfect thermodynamic equilibrium, a state where the substance is simultaneously in all three forms. The triple point of water is defined by a very precise set of conditions. It occurs at a temperature of 0.01 degrees Celsius, 273.16 K, and at a pressure of 611.657 pascals, or 0.00604 atmospheres, which is slightly less than the pressure found at Earth's surface. Under these conditions, water can exist as a solid, ice, a liquid, water, and a gas, water vapor, all at once. The temperature and pressure at the triple point are so finely balanced that all three phases are in equilibrium with each other, meaning that the rate of transition between the phases is equal in all directions. Water at this temperature and pressure will constantly shift between ice, liquid water, and vapor, without any one phase dominating the others. The system remains stable as long as the temperature and pressure are maintained precisely at the triple point. This unique situation is a direct consequence of the nature of phase transitions in matter. Normally, substances undergo phase changes when either the temperature or pressure is altered. For instance, when the temperature of water is increased, it turns from a liquid into a gas, and when the temperature is lowered, it freezes into a solid. The triple point occurs when these phase transitions happen at the same time under very specific conditions, creating a delicate balance. The temperature and pressure conditions required for this state are so precise that it can only be recreated in controlled laboratory environments. The triple point is not just a curiosity in the study of water. It is a key concept in thermodynamics, the branch of physics that deals with the relationships between heat, energy, and work. The triple point is used to define the Kelvin temperature scale, one of the fundamental standards in science. In fact, the Kelvin scale is based on the triple point of water. This allows scientists to have a precise, reproducible reference point for temperature measurements across all scientific disciplines, from physics to chemistry to engineering. Without the concept of the triple point, it would be difficult to establish a universally accepted temperature scale that applies in all situations. Interestingly, the concept of the triple point is not exclusive to water. Every substance has its own triple point, defined by its unique temperature and pressure conditions. For example, the triple point of carbon dioxide occurs at a temperature of -56.6 degrees Celsius and a pressure of 5.1 atmospheres. Just like water, at this specific temperature and pressure, carbon dioxide exists in all three phases, solid, dry ice, liquid, and gas, simultaneously. The study of the triple points of different substances is essential in fields such as materials science and engineering, where precise control over the phases of materials can lead to innovations in manufacturing, energy storage, and other industries. The ability for water to exist as a solid, liquid, and gas at the same time is not only scientifically intriguing but also plays a role in understanding the behavior of water in extreme environments. For example, on other planets or moons in our solar system, the conditions might be right for water to exist at or near its triple point. The low pressure and cold temperatures of Mars, for example, mean that water can exist in all three phases, albeit in very different environments than we are used to on Earth. Scientists have studied how the triple point of water might influence the formation of clouds, precipitation, and ice on other planets, contributing to our understanding of planetary climates and the potential for life elsewhere in the universe. While the triple point of water is often discussed in theoretical and scientific contexts, it also has practical applications in industrial and laboratory settings. Understanding and manipulating the triple point is important for the precise control of substances in various processes. For instance, in the field of cryogenics, the triple point of a substance is often used to calibrate thermometers and ensure accurate temperature measurements. By creating conditions where water can be brought to its triple point, scientists can measure the temperature of other substances with exceptional precision, leading to advances in scientific research and technology. Another fascinating aspect of the triple point is the behavior of the water itself during the transition between phases. When water reaches its triple point, the liquid and solid phases are in a state of equilibrium, meaning that the ice and the liquid water are in a constant state of transformation. Likewise, the gas phase of water exists in equilibrium with both the liquid and solid phases. This is a dynamic process, where the molecules of water are constantly moving between the phases, absorbing and releasing energy as they do so. This dynamic equilibrium gives rise to the fascinating property of the triple point, where all three phases coexist in a delicate, ever-changing balance. The triple point of water is a remarkable phenomenon that not only deepens our understanding of the behavior of substances under extreme conditions but also has practical implications for a wide range of scientific and industrial applications. It serves as a critical concept in thermodynamics, helping to define the Kelvin temperature scale and providing insights into the nature of phase transitions. From understanding the potential for liquid water on other planets to improving temperature measurements in industrial processes, the triple point offers both scientific intrigue and practical utility, making it a key element in the study of matter and energy.